Hi, everyone, and welcome to yet another instance of our Global Online Meetup sessions. Good morning, good afternoon, good evening, based on wherever you're tuning in from, because I realize we have a global audience. I'm your host, Divya Mohan, and I work as a principal technology advocate at SUSE. And I'm so incredibly glad that you've joined us today from across the world, like I said before, to learn more about our K3k project. Now, K3k is one of the projects we've devised here at SUSE, created really to address multi-cluster Kubernetes as a concept. And I am not the person who's going to be speaking more about it. I will have my colleagues, Rossella and Jean-Phillipe, come on and explain that more in a couple of minutes. But to set the stage for the discussion that's going to happen over the next half an hour, 45 minutes, 1 hour, based on the number of questions that come in, I wanted to request that since this is a learning environment, any questions that you might ask, wherever you're asking them, on the chat, in LinkedIn, or on YouTube, or even in the comment section on Twitter, please be mindful that you are interacting with a wider audience, and please be courteous while actually having said interactions. Second thing is, we know you have questions. You obviously do, given that this is a very hot topic in the cloud native universe today. And we want to get to each and every one of them. So it's a request that you post them on the chat, and I will be relaying them to our presenters and my colleagues over the course of the presentation as we cross each section. So that's basically just the ground rules, and I'm thrilled to bring on my colleagues today, Rossella and Jean-Phillipe. Welcome to the both of you. It's absolutely wonderful that we get to explore the K3k project today with both of y'all, and I can't wait to showcase the awesomeness that is the project. And I can't wait for the presentation, really, and the demo, because I hear we have a secret demo lined up. So,
We do.
welcome to both of you. Yeah, I think we can kick off the presentation if that's okay with you all, and take the questions as they come in. Yeah, sounds good.
Yeah, great. Thanks,
Absolutely.
Divya.
Thank you.
All right. Okay. We have our very first slide, I guess, with the title and everything else. Yeah, so you can kick it off.
Great. So yes, welcome everybody. You're here, so you want to know more about virtual clusters and how to handle multi-tenancy. And we will talk more in detail about K3k, which is an open source project that we founded in SUSE. So few words about ourselves. So I'm Rossella. I'm an open source developer. I've been part of several open source communities. I was, for example, co-reviewer for OpenStack Neutron. I was a member of the technical advisory committee for the Linux Foundation networking. So as you can see, most of my open source experience revolves around virtual networking. And I'm here today because I had the pleasure to lead the team in charge of virtual clusters at SUSE. So now to you, JP.
Thank you. Wow, quite amazing. So yeah, welcome everyone. So I'm Jean-Phillipe, or JP, an humble open source contributor. I'm a product manager at SUSE and specifically working on virtual clusters and the open source project K3k.
Great. So let's actually take a step back and think about what kind of problem we are trying to solve here. So if you remember 10 years ago, I don't know if you were already working 10 years ago, but I was. And writing code for me was mostly about using my laptop. I had everything that I needed there. I had a local environment and local testing virtual machines and so on. But if you look at what people are doing now, so most developers, I would say, they don't rely on the laptop machine, or because it's too limited. They basically use cloud computing resources. So those resources are paramount to be able to do our job. And this is putting lots of pressure on the people that are actually taking care of the infrastructure. Because basically, as you can see in the picture nicely generated by the AI, every team wants resources, and they also want to be isolated from other teams. So this is posing a new set of challenges on the people managing the infrastructure. So one possible solution, and it's the one that is simple and straightforward, is to use what's already available in Kubernetes. So to be honest, Kubernetes is a platform that was not really designed to isolate. It was more designed to share. It's a platform where you can easily spin up your container and have your application up and running. So what's already available in vanilla Kubernetes is, I would say, kind of limited if your use case require a high level of isolation. But let's look at what's there. So the first thing that comes to mind is namespaces. If you look at the documentation, it's namespaces are defined as a way to isolate resources. So you can see it as a way of partitioning the Kubernetes API so that different teams that are assigned to different namespaces actually get a different URL so they can see and manage a different set of resources. But this doesn't really help with permission because it's it's not helping in defining who can modify a resource, who can delete a resource, who can access a resource, and so on. That's why we need airbag. And this is already provided by Kubernetes. Another common problem that you have when sharing the same infrastructure with other teams is that you might have a noisy neighbor. You probably know what it is, but for the people who don't know, basically think about, you're working with another team, and that team is consuming a lot of a specific resource. So for example, let's say the team is developing an app that is consuming a lot of CPU. This is going to impact you as well because you don't have your dedicated CPU. You're basically sharing it. So if somebody is using too much of it, you will also experience slowdowns. So that's why we have quotas in Kubernetes, which is a way to set a limit to the resources that one tenant might use. So with these three concepts, you can come up with a way of isolating your tenants. It's a kind of a puzzle. That's why I put that picture, because there's no ready recipe. It's up to you to configure this construct and to maintain them. So it might be good for some use cases, but definitely in the realm of multi-tenancies, it doesn't solve all the use cases. Other drawbacks that we have is that, for example, there's no IO isolation. So IO is a global resource. So for example, if you have storage, you will share it with the other teams. There's no way to partition it. Related to that, there's no network bandwidth isolation. So if we are talking about virtual networks, that's a way to kind of set permission, which is network policies. But they don't help with the bandwidth because it has to do with the underlying networking, and that's also shared between the tenants. And another kind of very pressing problem, and this probably led to the creation of virtual cluster, is that no conflicting CRDs are allowed in the same cluster. So CRDs are a custom resource definition, and it's a way to extend the Kubernetes API. Every CRD has a specific version. So for example, if you have two teams that are working at the same CRD and they want to test different version, if they share the same cluster, that's not possible in Kubernetes. So that's why there's another possible approach, which is basically to have one dedicated cluster per tenant. So if you think, if we can use an analogy, so a cluster is a house. So in this case, you give each tenant a house, which is great. I mean, that's what I would want from my provider. But of course, this comes with drawbacks. It's really expensive because creating a cluster and maintaining a cluster is expensive. It's not efficient because it's really hard that a team alone will use efficiently a whole cluster. It's complex because if you manage maybe 1, 2, 3 clusters, that's okay. But if you have tens of clusters, that's really difficult to manage. And it might be slow to procure depending on the procurement process that you have in your company, but usually it's not so easy to get a full cluster. So that's why we have developed alternative solutions, virtual clusters. So if we go back with the house analogy, you can think of a virtual cluster as a flat in the house. So the house is divided into several flats. Every flat has their own door, so their API, and their own rules, so RBAC and CRDs. And the host cluster, which is the host cluster is the cluster where the virtual clusters live. The host cluster takes care of the global resources. So the plumbing, electricity, which mean networking, storage. There are already several implementation of virtual clusters, but we can group them in two categories. One is the nested approach, and the other one is the control plane as a service approach. So in the nested approach, and you will see it more in details with JP later, the idea is that, so we said a house is a cluster, then you have a virtual cluster that is a flat. Then for the workloads of the virtual cluster, you kind of partition the flat into rooms and you use them to run the workload. So what it means in practice. So you have a control plane. So the control plane is like the Kubernetes API, etcd, everything that you need to run Kubernetes. You have the control plane of the virtual clusters that runs as pod in the host cluster. And then you have the workloads of these virtual clusters that run as pods of the nested Kubernetes instance. So it's kind of mind-blowing a bit, but if you think the maybe more familiar concept of a nested VM is this kind of the same idea. So the other approach is control plane as a service. In this case, the control plane of the virtual cluster, again, run as a pod in the host cluster. And the workloads of the virtual clusters, they actually they can run in dedicated nodes, or in the case of K3k, they can be basically reflected in the host cluster. So you have the control plane running as a pod of the host cluster and the workloads of the virtual cluster running again as a pod in the host cluster. And you'll see that in more detail with JP. And to you, JP.
Amazing, thank you. Okay, we can go to the next slide. All right, so let's dive a bit into K3k and the architecture. But first, yeah, let's start with that. First and foremost, so K3k, as Rossella said, is a fully open source project. It's a community driven. And the exciting part, I'm really exciting about that, it's because what we're seeing here on the red line is the traction we get with that project right now on GitHub, the star we have, and we are not even GA yet right now. Spoiler alert, we'll be GA really soon, but we see that more and more people, users trying to use and leverage that technology. So that's really great. And well, if you want to start playing with K3k, then you can strictly jump into the GitHub repo, follow the README, and it's as easy as that. And just a bit of disclaimer. So if you also run for Prime user, so we get additional integration, and yeah, using that to venture a fleet of SUSE observability. Right? But K3k is a full open source engine. All right, we can go to the next one. So Rossella, so you mentioned two different kind of implementation, right? So that's why inside K3k, we're actually offering two different kind of architecture. One is called the virtual mode, one is called the shared mode. So basically the virtual mode is a fully running Kubernetes cluster with server as pods, agent as pods. And K3k is only deploying K3s virtual cluster because K3s fits really well that environment because it's lightweight, it's fast. So that's what we want when we want to use virtual cluster. And in virtual mode, one key concept here is that the workloads are running fully isolated inside that Kubernetes cluster. So it's really great for platform team who want to test new CNI, new CSI, new policy agent without disturbing the rest of the users. We'll see a bit more use case in the slide later. But that's really where really the virtual mode really shine for us. And the shared mode, it's based on a component called virtual kubelet that actually act as a proxy between the host cluster and the virtual cluster. And in that mode, the pods, the workloads are effectively running on the host cluster. So from a virtual cluster user perspective, it's really great because they can consume shared services offered at the host level. So we are talking about networking, storage, and security. And that will come also on the slide, and that will be the topic of the demo. So yeah, share mode is really, oh, sorry. Just, so share mode is really great when, as platform team, you want to simplify the life of the user. And so your user don't need to bother with storage solution, how to expose workloads. It's all a platform team construct. And that's also the mode that allows you to get access to host level resources, such as GPUs. So now if we dive a bit into the architecture of each mode. Yeah. So on the virtual mode, basically on the host cluster, it all starts with the K3k controller. So that's the first piece you want to deploy. And that will react to K3k cluster resource definition, where you are going to express the desired state of the virtual cluster you want to deploy. In that case, the virtual mode. So once you apply that resource, and whether it's coming from the custom resource directly or the K3k CLI, the Rancher UI, or our CAPI provider, it will all basically create the same resources that the controller will react on. And then it will deploy inside the targeted namespace on the host cluster, your virtual cluster. So in the virtual mode, you'll see a couple of pods running. One is called the K3s server and the K3s worker. But that's basically it. Right? Everything else is completely inside the virtual cluster. So you will connect to that cluster. And once connected, then you will be able to see, for instance, that there is my app running that's running an Nginx pod, right? So, and then from that point being, you can do whatever you want. It's your full Kubernetes cluster. And one very interesting part here is that we are proud to say that it's also a fully conformance Kubernetes cluster. So we ran the CNCF conformance test, and it has been certified by the CNCF. Now, if we look at the shell mode, thank you. Basically, start with the same thing, right? We still have the controller. It will react to the same kind of resource. But if we take a look at what's happening now inside the host cluster, in the namespace of my virtual cluster, you will see a bit more than just the K3s and the virtual kubelet. You will actually see the pods, the workloads running. But if we take a step back and we go through the lens of a virtual cluster user perspective using the share mode. So if you want to deploy your own controller, you have your apps, you have your CRDs, airbags, everything. So you connect to your virtual cluster and then you will deploy everything. And it will be running. It will start. The airbag will be enforced. and you will be able to create your custom resource. Your controller will react to that and do the appropriate change, create apps, whatever. So from that perspective, you are really interacting with the real Kubernetes cluster. You don't know it's in shared mode actually. But the magic happened at the host level. So if you take a look at what's happening on the host, you actually will see that the pods and everything that is mandatory for the pods to run, that will be shared with the host cluster. So you will see the pods definition, config map, service, persistent volume claim. And this is the kind of resources that will be actually shared with the host cluster. All the rest, so the CRDs, the airbags, everything is actually kept locally to the virtual cluster. They are not reflected back to the host cluster. So that's really a key point of that virtual cluster. And this has actually a lot of benefits, right? So as I said, virtual clustering user in shared mode, they don't need to care about networking. They don't need to care about the storage provider because it's all happening at the host level. So as a platform team, you really lower the cognitive load of your user and you are providing your own set of solution. So it's pretty powerful. And one latest addition that we just add, and I will show you that in the demo, is that we're also syncing ingresses resource now. So meaning you don't even need to bring your own ingress controller. You don't even need to take care of your certificates. It's all now a platform construct, and the platform team own that pieces. So on one side, it's really powerful for the user because they don't need to, they just need to take care of their apps, and they have the full capabilities and they're admin of their environment. They can do whatever they want. Actually, on the other side, the platform team, they have more control because they control what kind of storage is available. They control how certificates are created, how applications are exposed on the network. And one key benefit for the platform team is that because workloads are running in the host cluster, if you have your observability stack on the host cluster, you also observe what's happening inside the virtual cluster in shared mode without having to deploy an agent inside each individual virtual cluster. So it's really agentless kind of mechanism. And the same applies for if you're running a policy agent, right? Via Kubernetes, OPA, Gatekeeper, or Kyverno. The same will apply. You will be able to create guardrails, boundaries at the host level that will be enforced individually on the workload of the virtual cluster without having to deploy a policy agent into the virtual cluster. So at the end, it's a really great way, and it's also true for the virtual mode, right? Great way for platform teams to provide more flexibility to their user, allowing them to self-serve themselves and to create autonomously virtual cluster without having the risk of breaking the host cluster, the infrastructure, while the platform team actually gain more control on what's happening. So it's really a win-win situation here. And speaking of control, so that will be the next slide. So we went a bit beyond that, and we introduced a new concept, which is the virtual cluster policy. And this policy is really aimed for the platform team to put guardrails in place and to define how user could create virtual cluster, provide consistent configuration, security settings, resource management rules. And all of that aims to really simplify how you approach multi-tenancy in Kubernetes uh, using K3k technology. So a virtual cluster policy, it's a cluster scope resource um, that you create, and then you apply that to specific namespaces, and the virtual cluster that you will create inside those namespaces will inherit from a bunch of configuration, a bunch of security from that policy. And there is nothing that the user can do to circumvent those settings. So I think that's it. Okay, yeah. Um, so virtual mode or shared mode, right? So it will be the biggest question now. How do I choose? So we bring some example that we share on the GitHub repo. Um, so it will really depend on the use case. If you want to do some advanced testing, for instance, you want to test a new feature gate of Kubernetes, you have a developer asking for that, then they can use virtual mode because they will control the Kubernetes distribution. They will be able to enable the feature flag and do their advanced testing. If you are a platform admin and you want to test the impact of an upgrade, you can use the virtual mode for that. You can do your deployment, test the upgrade, and see what's happening. And the similar. So I was saying, so can test new CNI, new CSI. So yeah, those kind of advanced testing are really great for virtual mode. And on the other side, for any, let's say, traditional apps controller that your developer wants to run, they're asking you about a cluster for that, then you can use share mode. And then you will benefit from the share mode, the observability in an agentless fashion. And they will be able to get access to a virtual cluster in a minute, and which will consume half a gig of RAM, 0.2 vCPU, and they'll get their own Kubernetes cluster. Cool. And I think now it's time for the demo. Oh, no, I don't think the slide. Oh, okay, let's see. Right, let me now share my screen because it's time for the demo.
All right, let me just bring that up. Give me a moment, JP. So sorry. All right. I think this is visible enough for my grandma eyes as well. So, go ahead, JP. Show us the magic. Wait.
Amazing. All right, so it all starts with the K3k CLI to get started really easily. So the latest version is 0.3.4. And well, to create a cluster is as easy as that, right? So just simple command, create my cluster. It will create for me the namespace and will create a virtual cluster inside my host cluster. We don't want to spend much time seeing stuff, so we want to see what's happening behind the scenes. So if I take a look at the pods running inside that newly created namespace, I can actually see that I have the virtual kubelet deployed, the server is being provisioned and being running. So actually, by default, if you don't specify anything through the CLI, it will create you a virtual cluster in shared mode, one server, and then enable the dynamic persistent storage. Depending of if you have a default storage class available or not, or if you don't, then it will be an ephemeral mode. But all of that, you can specify that through the CLI directly. So you have a bunch of arguments that you can provide, and you will be able to tailor your experience using virtual cluster. Now we just need to wait a bit. It takes roughly a minute for the server to be up and running, and then you'll be able to access it. So the CLI, once it's done, is providing you a command to run to export the kubeconfig. And once it's done, then you have access to your virtual cluster. As easy as that. You know, in less than 1 minute, you have now access to a full Kubernetes cluster with almost nothing in it because you don't need anything to run, especially in shared mode, because you are actually using the resources of the host cluster. All right, so that's one way to create a virtual cluster. I will show you another one because it will allows you to use this new feature I was talking about, so the syncing REST stuff. So instead of using the CLI, you can also use directly the cluster resource definition. And that can be really powerful if you want to do a full GitOps approach and you don't want to, embed a CLI somewhere. So you can just rely on plain Kubernetes manifest and you'll be able to deploy your virtual cluster. So let me create a namespace and then I will apply this manifest to the namespace. All right, so now what? So in order to connect to that cluster, I need to get access to the kubeconfig. So actually, there are two ways to get access to the kubeconfig. For my previously created cluster, for instance, automatically we create a kubeconfig secret that you can rely on to get access to your virtual cluster. So again, if you want a full GitOps, full Kubernetes native way, that's how you want to approach that. So you'll get a secret, then you can get that secret, get the kubeconfig, get access to your cluster. And if you want to use the convenient way, so we will provide you, so with the K3k CLI, you can also instruct to generate the kubeconfig, you need to pass the namespace and name of the cluster. It will wait for the cluster to be created and then prompt you the kubeconfig. And again, what's happening behind the scene. I always like to see what's happening under the hood. All right. Just need to wait a couple of seconds, I guess, for the cluster to be running. And so in the cluster resource definition, so you can actually pass a bunch of arguments. So that's how you can get access to really the latest feature we provide. And yeah, there are a bunch of parameters that you can use. Okay. Gonna test the access to my cluster. All right. So see, I've created two Kubernetes cluster in less than 2 minutes. Oh, how wonderful. All right, so now I want to deploy an application. That's why I'm creating a virtual cluster. So I have a really simple application here, but it's using a persistent volume claim. So it's asking for a storage, a volume, simple deployment with 2 replica, a service, and an ingress. If I take a look at, again, what's running inside my virtual cluster, I have nothing. I don't have any storage provider. I don't have any ingress controller. So now let's deploy this application. If we look at what's happening behind the scenes, so we can see that we have our application that is being created and that are now running. So the great part is that I've asked for a volume. The volume is effectively created on the host cluster because that's where the volume matter for the application. But for the user experience, what we did is that we will create also a fake volume inside the virtual cluster so the user understand that a volume has been provisioned. You don't need to rely on information existing only on the host cluster. Right? Everything is available on the virtual cluster. And now, so I did deploy an app, right? It's on SUSE.webinar, and that will be a good transition to actually the rest of the demo. So let me stop sharing and share a different screen.
Let me bring that up. All
Oh,
right.
thank
Yeah,
you.
I guess the Rancher screen is up right now.
All right, cool. All right, so I want to access what actually this application now, and here we go. So I can access my application. And again, from the virtual cluster user perspective, I didn't care about the ingress controller, certificates. I could have included certificate, but networking storage doesn't matter. I'm just working on my app and delegate all of that to the platform team, to the host cluster. All right, and for the last bit of the demo, I want to show you how you could also create a virtual cluster through the Rancher UI interface. So actually we'll provide for Prime user an extension so they can actually create a new kind of cluster called K3k. And then, well, you also have cluster. All right. The idea is that now I need to pick an host cluster. In that case, I only have one option. The neat part inside this UI is that if the engine K3k is not deployed, you'll get a neat button here that press install K3k. So in one click, the controller will be deployed and you'll be good to go. Then you can specify which K3s distro you want, and it will give you the list of supported K3s distro for that rancher. Which mod, then the storage, it will pick which storage class is available, or if you want to do an ephemeral mode. So ephemeral mode, basically you don't get any storage, and it's really great for if you have a CI/CD that needs an ephemeral environment to do one test and then you tear down that environment. That you don't need to provide to get a storage for that. So you choose ephemeral, and that's basically it. Then you can configure a bunch of parameters. One key thing here that is really interesting and differ a bit of just K3k is that by default, when you create a virtual cluster through Rancher, you will be able to access that virtual cluster through the Rancher proxy. So you don't need to expose directly to the outside world your virtual cluster. Rancher will do the proxy for you. But if you want, you can choose to directly expose the API through the Ingress, load balancer, or node port service. And then just click on create. And the cluster will be created. So it takes just a bit more time. So it's around 3 minutes for the cluster to be created and imported back in Rancher. I don't want us to spend 3 minutes staring at the screen, so I've created the cluster just before. So as you can see here, once created, once imported in Rancher, it's actually real. As a real Kubernetes cluster, you can do whatever you want. Like through Rancher, you can create project namespace, manage user permission, project and member. From Rancher perspective, it's a real Kubernetes cluster. Yeah, that's about it for the demo.
Well, I mean, I don't see questions, so I am just going to ask questions that I have.
Sure.
First up, I know that this is based on the K3s Kubernetes distribution, and we default to container D. Is there support for other container runtimes as well included, or have we tested that out? I'm just asking out of curiosity. We default to container D as well with a K3k, I assume. Is that right?
Yeah, I don't think we tested and other container runtimes, but so we should have on the call also the engineers who worked on the project, so they might have a better answer.
All right. And you mentioned, JP, earlier on that we are going to go GA soon. So I'm looking forward to that announcement. But between you and Rossella, what are some of the roadmap items that you can give our audience a sneak peek of for the next quarter or couple of months? Like, what are the features that we are actively working on uh, within the K3k team to make this a better project for the multi-cluster requirements of our community and customers?
That's a great question. Yeah, I can provide some ideas, some direction. So one thing we are actively working on. So For us, virtual cluster, they are meant for fast ephemeral environment as well as production use case. And we really want to double down on those production usage. So right now we are working on the upgrade path. So how do you manage the upgrade of your cluster, and what will coming in next couple of months is also how do you backup and restore your virtual cluster. So we want to work on that kind of feature, that kind of experience. Um, and then when I mentioned that the virtual mode was 100% CNCF compliant and has passed the test and certification, well, we want to do the same for the shared mode. So because of the nature of the sharing between the host and the virtual cluster, it's a bit more complicated to reach that point, but we are really close and working hard on having that certification.
Right. And I'm not sure what the question is, but here I have a question that's going to pop up on the screen, which is Postgres as K3k backend worked question mark in the bracket kind. Uh, so
No,
I
we have an issue about that, but we haven't fixed that yet.
okay. So this is a person who has surfaced from the issues, probably.
Maybe, I
As
don't know. So currently, Postgres is not supported. We use a TCD.
Yeah, we
right.
use the
And
embedded etcd. Yeah.
okay. So probably this is a request for feature coming through the YouTube comment here. Um,
So it's already a GitHub issue open. So if you want, you can go on the
yeah,
GitHub issue and do a little plus. So we know that it's an important feature for the community.
yeah, and that's the best way to be honest, because we need to understand what is important to our community, like JP said, and the best way, obviously, like getting the eyeballs of the team here is important, but also the wider team working on this also needs to prioritize. So upvoting that specific issue. I'll post the link to that hopefully in like a couple of minutes if I can get to it. But otherwise, you can find it in the YouTube comment section, and you can directly take it from there. Uh, James has mentioned, will this be integrated with Harvester to Salesforce Rancher? Currently, the recommendation is B cluster from Loft.
So we haven't tested it. Maybe this is something we should add to the roadmap. So of course, Rancher is, so you can use our Harvester in Rancher. We just haven't tested how virtual clusters would work. This is something we can verify and get back. It might be that they work out of the box. It might be that we need to tweak something. But yeah, it's a good point.
Can even say that it's on the Harvester roadmap. We're working on that integration.
All right. I am not going to be able to say the person's name because it's just showing up as LinkedIn user on StreamYard. So sorry about that. But are there features that require Rancher server, or is Rancher server a completely optional integration? Which I believe it's a completely optional integration, but you can go ahead and clarify that.
Yeah, it's completely optional. I mean, K3k is an open source project, so you can use it. And the Rancher integration is totally optional. Of course, through the Rancher integration, you get features and configuration that are easy to manage. But yeah, then that's up to you.
All right. I will wait for a couple of minutes before closing this out because I realize that we have run overtime or are close to running overtime at this point. All right. So there's another question that's come in. If I have an instance already, can that instance join the cluster in shared mode?
Yeah, an instance of what? I assume if you
Yeah, I'm
have.
not sure to understand.
So if you want to add a
Apologize,
node
Fabian.
or
Yeah. So if you can provide more clarity, Fabian, if I got the username right, could you provide more context to this so that we can provide you the right answer? Um, In the meanwhile, James has come back with the Harvester bit that we were talking about. K3k doesn't currently work in Harvester due to the load balancer implementation. So he's already tested this out uh, before you all did. So essentially, yeah, we probably need to test it out a little more to see what tweaks are required and what needs to be worked. But thank you so much for
So,
flagging it.
so James, I can recommend you to jump onto the GitHub repo and open an issue if you have done some testing. That would be really helpful.
Yeah, and like he mentioned in the first case, right? Like we want to know what is your opinion on things, because that's the best way we can go ahead since this is very much community driven. So if you would be so kind to actually open the issue against the rancher slash K3k GitHub repo, it would be extremely helpful. Um, all right. We are a couple of minutes over time right now, and thank you so much, both of you. This has been a very insightful session, and I'm sure. Okay, there is a Sen who has responded to it. Uh, and I will let our audience check it out in the comments as well. But thank you so much for your time. I realize that y'all have work to get back to, and potentially, since we're running over time, our audience might also want to be tuning off. But this is to say that this was a very insightful session, and I personally learned a lot from it, and I'm sure so did our users and our community, and everyone who tuned in. If you have any questions, the best way to get in touch is through the Rancher user Slack as well as the GitHub repo. The GitHub repo has been posted in the live chat as well as on LinkedIn. So please go there and upvote on issues that you feel are pertinent to your use case or are important to you personally. And if you have questions, we're always available on the Rancher Slack as well. That will also be posted. But in case you're not aware, it's slack.rancher.io. And it's as simple as that. You do not need to have like this is the Slack link. You just need to copy paste this into your browser, and you should be able to join our Rancher user Slack as well, where you can ask the team questions. With that, JP and Rossella, I'm going to let you go and get back to your respective lives. Any parting words that you'll want to give to our audience?
Not really. Thanks a lot, Divya, for hosting us, and
Yeah.
thanks a lot to the people who joined.
Thank you so much, and have a great day and rest of the week, everyone. Bye, and see
Thank
you in
you.
another.
Thanks. Bye bye.
Bye bye.
Bye.